We're going to continue on here in lesson 10.3, finishing up our last few examples. And this has been this has caused some problems in the past, so make sure you're listening as I go through this. Now, they're going to give you logs in different bases. Okay, the log key on our calculator is base 10. Okay, we cannot do some of this stuff with that logarithm key on our calculator if we're not in base 10. And we'll look at change of base formula and stuff like that coming up in the next lesson here, but in the next lesson or two. But what we want to do here is they're going to give you the log of something in certain bases. We want to express the numbers we're dealing with as products, quotients, and or powers of whatever base we're dealing with of the given log values, so that we can apply one of our three logarithmic properties. So notice what they give me here. The log in base 5 of 2 is about or approximately 0.4307. We want to figure out log in base 5 of 250. So I want to be able to express 250, or what I'm trying to find the log of, as maybe a product of two things dealing with the given logs. Now, we're only given one log in this. Notice I have a base of 5, and it's the log of 2. So how can I express 250, kind of break it down, either products, meaning multiply, or products of maybe a power on one. Okay, so you really got to think here. Now, 250, 2 goes into it 125 times. Okay, so the reason I want to do a 2 is because they're giving me the log of 2. The log of 2 in base 5. Now, how could I express 125, because we don't really have that number over there, as, well, 2 doesn't go into it, so that isn't going to help me. But you can also use the 5 here. The base is 5. And can I express that as 5 to a power? And it is. This can be expressed as 5 to the third. So what I'm going to do is I'm going to break 250 down into 2 times 5 to the third. So the log, the one we're trying to find, is this. What we're going to do is we're going to, and we got to stay in the same base, we're going to express 250 here as 5 to the third. I'm going to put the 5 to the third first times 2. It doesn't really matter which one you do. All right. Now, let's apply our logarithmic rules. If I have a product right here, I can break this down into the log of 5 cubed plus the log in base 5 of 2. Now, if you remember our inverse property, this right here, if this base is the same as this, the log in base 5 of 5 cubed, your answer is going to be 3. Log in base 5 of that base to a power basically is equal to that. That was one of the inverse properties of logarithms. So that's 3. And this was given to me. That's right here. The log in base 5 of 2 is about 0.4307. So I would add those two together, and I would get approximately 3.4307. Okay, so you're going to use your logarithm properties, sometimes an inverse property, if you're representing it as a base to a power, whatever base you're dealing with, to be able to do it. Okay? Now, notice on the next one. They give me two approximate logs in base 6. Log of 8 and the log of 32 in base 6, approximately what they're equal to. Here's what we're trying to find. So I want the log of 4 in base 6. I want to be able to represent 4 here using 8 and 32, or possibly our base of 6. How can I represent that? Now, if you notice, that number is smaller than all those numbers, but think about the 32 and the 8. The last one we used the base on, we use the 5. But if I think of 32 and 8, how can I get to 4 from that? I'm not really breaking down prime factorization. Okay, 4 is really 32 divided by 8. And the reason you can use division is we have a rule that when we have the log of a quotient or division, I can use the property that says I take the log of 32 and I subtract the log of 8 in whatever base we're in. Now notice, each of these were given to me. So the log of 32 is about 1.9343, and we're going to subtract the log of 8 in that base, which is about 1.1606. And what's it approximately equal to? If you actually do that on your calculator, subtract those two decimals, you get about 0.7737. All right, last problem here in this section. Let's extend the page a little bit here. We are given the log of 6 in base 5, and we're trying to find the log of 216 in base 5. So 216, how can I express that using 5s and 6s? Okay, now 6 goes into it 36 times. Well, 36 is 6 times 6. So this is really, if I bring all this together, 216 is 6 cubed. So we don't even have to use the base of 5, it's 6 cubed. So what I want to do is I want to go the log of 216 in base 5 is equal to the log of 6 cubed in base 5. I'm just representing 216 as 6 cubed. Now the rule is, now I don't use the inverse property here because these two things are not the same. That's not equal to 3 like it was earlier when we had the log in base 5 of 5 to a power. But we have a rule, logarithm property, that says this comes down in front. So it's 3 times the log of 6 in base 5. And we're given this. So this really becomes 3 times, notice this is what the log of 6 is equal to, 1.1133. So if you actually take 3 times that, you get about, and you should always use your approximate symbols here, 3.3399. These are tricky because you got to know how to represent the numbers to be able to use the logarithm rules and properties.